Okay, hi, my name is Mariela Gonzalez, and I'm going to be deriving the equations for v1 prime and v2 prime from this equation up here. And in order to do that, we have to take into account the coefficient of restitution, which is also known as E. And that is basically the coefficient, it's the ratio from the speed before and the speed after the collision, since we're working with collisions. And this is the equation for the coefficient, and from here we just manipulated it to have v2 prime on one end of the equal sign and v1 prime. And then these two values we're going to be using to input into here to derive the formula equation for v2 prime and v1 prime. We're going to start with v1 prime. So I'm just going to rewrite this. And instead of v2 prime, we're going to input this. So we're going to rewrite it. Next, we're going to distribute m2 to these three values. And then we're going to go ahead and add m2 v1 to both sides, and subtract and then add m2 v2 to both sides. So here, since they have a common value of v1, you can distribute v1 out and you would be left with m1 minus m2 times v1. And since these two are the same, it's m2 v2, that's technically 2 times m2 v2. And here you're going to be left with m1 v1 prime plus m2 v1 prime. Distribute the v1 prime out and you're left with m1 plus m2 v1 prime. Now to get v1 prime by itself, divide the whole thing by m1 plus m2. So v1 prime equals m1 minus m2 v1 plus 2m2 v2 over m1 plus m2. That's your equation for v1 prime. And we're going to continue with v2 prime. Okay, can I borrow the napkin? The one that I used? Thanks. So it's theoretically the same process. The only difference is that now instead of inputting v2 prime, we're going to input v1 prime. So I already have the equation pre-written from the last time, so I'm going to rewrite it. m1 v1, m2 v2, and v1 prime is when we're going to input these values. And then just bring down the rest. From there, we're going to distribute again, same process. From there, we're going to add m1 v1 to both sides and subtract m1 v2 to both sides. Over here they cancel out. m1 v1 plus m1 v2 is basically 2 m1 v1. And then over here, since both of these have a similar value with v2, you can just distribute it out and you would be left with m2, 1 second, yes, m2 minus m1 v2. And then on this side, since you have the similar value of v2 prime, you distribute it out. And then to get v2 prime by itself, you're going to divide the whole thing by m1 plus m2. So v2 prime equals v2 prime equals m2 minus m1 v2 plus 2m1 v1 over m1 plus m2. Yes. Okay. So now those two values will be used for questions 10 and 11 and inputted correspondingly to whatever the question is asking you. And these questions, they are elastic, and in question 10 they don't give you the masses, but question 11 they do. So I'm just going to really quickly rewrite what v1 prime 2 and v2 prime equaled. So v1 prime equals So that is how you derive these two equations from this equation using the coefficient of restitution. Now, using the two equations we previously just derived, we're going to answer questions 10 and 11. For question 10, it says that we have 3 different carts with masses 4m, 2m, and m. And the first cart has an initial velocity of VO, so it's unknown. So we're going to start by using our v1 prime formula. And we're just going to go ahead and input the different masses that they gave us. Take into consideration that for the second cart, VO equals 0. So this part of our equation is going to be canceled out. So we're actually going to be left with 4 minus 2m, which is 2m, over 6m, VO, which when simplified is 1/3 VO. That is the final velocity for cart 1. So and our v2 prime is actually going to be the v1 for the second collision, because the first collision is with 4m and 2m, the second collision is with 2m and m. So now we're going to solve for v2 prime in order to start solving for the second collision. So v2 prime, once again we're going to input our values into the equation we derived. So also keep in mind that VO for the second cart is 0, so this part of the equation is going to cancel out. And we're left with 4/3 VO as v2 prime. But that is not the initial velocity, that's not the final velocity for cart 2, because cart 2 isn't finished until after the second collision. So this is going to become our V1 for the second collision. So we know for the second collision, our V1 is 4/3 VO, and VO equals 0 because our third cart, it gives us in the question that VO equals 0. So once again, we're gonna solve for V1 prime and V2 prime. I'm gonna denote it as V double prime, only so that we don't get confused with the first collision because there is two different processes happening. So V1 double prime equals 2m minus m. And I'm not gonna write this problem because I already explained how it's gonna be canceled out either way. So I'm just gonna keep it like this. And once again, now the difference is that our VO is 4/3 VO. So after calculating it, our answer is 4/9 VO. That is going to be the final velocity of cart 2. And finally, we're going to solve for V2 double prime. I'm just going to go ahead and write it here. V2 double prime equals, I'm not going to put the first part of the equation as well because the V equals 0 and that's going to cancel out eventually. So our answer was 16/9 VO, and that is the final velocity for cart 3. And there you have it. So our final velocity for cart 1 was V1 prime, and we got 1/3 VO. Our V2 prime became our V1 for the second collision, which was 4/3 VO. With that, we were able to calculate V1 double prime and V2 double prime, which are the final velocities for carts 2 and 3. Now, question 11 is the same process, except you now know the mass. So you're going to input the mass into all of these m's. So our final answer will be in numbers, and it won't have necessarily VO present in the answer. So they tell us that cart 1 is m, cart 2 is 2m, and cart 3 is 3m, and m equals 0.4 kilograms. So our first cart was 0.4 kilograms, our second was 0.8, and our last one was 1.2 kilograms. And our VO was 1.3 meters per second. So that goes to show how VO is not going to be present as a variable in our answers for final velocities of cart 1, 2, and 3. And once again, we're going to use these equations to find our answer. So here I have inputted all of the numbers, and I put it just to reconfirm that VO equals 0, so this is going to cancel out. And once calculating this, V1 prime comes out to be negative 0.43 meters per second. this is the final velocity of cart 1, and the reason behind it being negative is that it's an elastic collision, implying that when it collides, it's going to bounce back, so it's going in the opposite direction. That's why the negative sign is there. So now we're going to find v2 prime, convert it to v1, and then find v1 double prime and v2 double prime. Once again, this part cancels out because VO equals 0. After doing the calculations, comes out to be 1.25 meters per second. But don't get that confused with it being the final velocity, because there is a second collision that comes into play. So we're going to save that thought. And we're going to say that for the second collision, V1 equals 1.25 meters per second, VO equals 0, because for the final third cart, VO is given that it is 0. So we're going to find V1 double prime and V2 double prime, which would be the final velocities of cart 2 and 3. I'm not going to write the part that cancels out due to the V equals 0, because I already demonstrated it in the first collision of this problem. So for V1 double prime, it became negative 0.25 meters per second, which is the final velocity for cart 2. And once again, it's negative because cart 2 bounced back from cart 3. So that is the final velocity of cart 2. Finally, we're going to solve for V2 double prime, which will be the final velocity of cart 3. So because it is an elastic collision, we're going to foreshadow that cart 3 is going to keep going in the positive direction, implying that our answer should be a positive number. So I'm going to go ahead and input them, of course excluding the part that has VO equals 0, because I already showed it previously in the first collision. After inputting the data and calculating, our answer was 1 meter per second, which is a positive number, which supports my statement that our final velocity of cart 3 should be positive since it is an elastic collision. So there you have it. That's the application of these two equations that we derived from m1v1 plus m2v2 equals m1v1 prime plus m2v2 prime, and of course with the presence of the coefficient of restitution E.